Okay, this is your first video on simplifying radicals. We're just going to basically be going through the first three lessons of chapter 11. The first lesson begins on page 616. What we need to talk about in the beginning is we need to define what is a radical. Hopefully, when I say radical, you have some idea. It's the square root sign, okay? And so when we're talking about radical expressions or simplifying them, we're talking about problems like 2 times the square root of 3, the square root of x plus 7, or maybe even the square root of 50. And the square root of 50 brings us into some important information for this video, and we're going to be talking about removing perfect squares. Hopefully, when I say perfect squares, you have some that might jump into your memory. If you recall back when Mr. Nashin was here, we encouraged you to memorize maybe the first 20 perfect squares, like 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, and so on, 100, 121, 144, etc. It's helpful to know those because we're going to talk about removing perfect squares, which is example 1 on page 616. And I want to go back to the square root of 50. If we talk about the square root of 50, 50 is a composite number, meaning it has other factors. So we could say 1 times 50, 2 times 25. 5 times 10, okay? When we're listing those factors, we want to look for factors that happen to be perfect squares. So, we look at 1 and 50, those aren't perfect squares. We look at 2 and 25, 25 is a perfect square. 5 and 10, neither of those are perfect squares. So let's change this to the square root of 2 times 25. Okay, well, 25 being a perfect square, the square root of 25 is 5. So 5 will come out like a coefficient times the square root of 2. Because the square root of 25 was 5, so we took it out of what Mr. Nashin used to say, radical jail, and then the 2 stayed in there. Okay, let's do a couple of other examples together. Okay, in your book, they use the example of 192. We did 50. Let's look at the quick checks. Let's try B and C together. B is negative 5 times the square root of 300. C is the square root of 18. We think about 300. Remember, we're looking for factors that are perfect squares. So we have 1 times 300. We know we're not ever going to use those because 1, yes, is a perfect square, but it doesn't change my number. So we have 3 times 100, 2 times 150. Oh, you might be saying, well, I already see a perfect square, 100. And what's left is a pretty small number. That's our goal, is to try to get as small of a number under the radical. So I have negative 5 times the square root of 3 times 100. Well, the square root of 100 is 10. So that means 10 comes out of radical jail. Okay, and we're only talking about positive square roots here. And it gets multiplied, though, by the negative 5 I already have. So that means it becomes negative 50 times the square root of 3. Okay. What do you think about 18? Well, I have 6 times 3, and I have 9 times 2. Are any of those numbers perfect squares? Ooh, that one has one. So I like to write it now, the square root of 9 times the square root of 2. Well, the square root of 9 is 3, so we pull the 3 out, and it becomes 3 times, not the square root of 3, 3 times the square root of 2. Okay, removing perfect squares. Okay, moving along, we're going to go to removing variable factors. Okay, again, similar to what we were just, whoops. Oh, you know what? I didn't put it in the right one. That's what I get. Moving variable factors. Okay, so when we look at example 2, we have a problem like this. The square root of 45a to the 5th. Okay, well, we're going to separate these into two things. We're going to look at 45, factors of 45. Again, we're looking for a perfect square. So we have 3 times 15 and 5 times 9. Ooh, perfect square. So 5 times 9. Now, when we look at our variables, when we talk about the square root of something, that's the inverse of squaring a number, right? So if I have the square root of a squared, these two things pretty much cancel everything out, and it's left a squared, or just a. So when I look at a to the 5th, I want to try to put it in groups of 2. And hopefully recall that when we have bases and we're multiplying them with variables like a squared times a to the 3rd times a to the 5th, we add these exponents. So when I'm going to break apart a to the 5th, I can break it apart as a squared, there's 1, a squared, and a. Okay? What happens when I take the square root of 9? It becomes 3. What happens when I take the square root of a squared? It becomes a. What happens when I take the square root of a squared? It becomes a. What am I left with under the radical? 5a. Now, should I write it 3a times the square root of 5a? No, a times a is the same as a squared. So 3a squared times the square root of 5a. Let's do one more just quickly here. Let's look at quick check 1, the square root of 27n squared. Okay? 27, factors of 27, 3 and 9. Hopefully they're starting to just pop out at you. So the square root of 9 is 3. Oh, I have an n squared, so I can pull out an n. So that's gone. This was now 3 times 9, n squared. N squared's gone, 9's gone, so it's 3n times the square root of 3. Lastly, let's look at multiplying two radicals. Okay? We're going to look at quick checks here because you have the examples in your book. We're going to look at the square root of 13 times the square root of 52. Okay? When you multiply radicals, it just becomes like this. The square root of 13 times 52. Okay? Now, you might have wanted to simplify beforehand, which you could have. But I'm going to go ahead and follow your textbook and take 13 times 52. That's 676. Okay? So I need to find the square root of that. So I need to find some perfect squares. Okay? Well, if I know my perfect squares, I know 20 squared is 400. So it's larger than that. I know 25 squared is 625. So that's close. So if it's a perfect square, I'm going to try 26. And it just happens that the square root of 676 is actually 26. So it was a perfect square. Let's try one more here. Let's try B. This one's a little different. 5 times the square root of 3c times the square root of 6c. I like this one. So I have 5, it stays out front like a coefficient, times 3c times 6c. Right? So keep my 5. Let's simplify 3c times 6c. What's 3 times 6? 18. What's c times c? C squared. Hopefully you might have this memorized now. The square root of 18 is the same as 3 times the square root of 2 because 9 is the perfect square. So now it becomes 5 times 3 because we brought the 3 out, and then c squared, so c square root of 2. 5 times 3 is 15, c square root 2. So that concludes our simplifying radicals video for today.